Kia ora Year 12 and Year 11. This is going to be a very short video going over a trapezium rule problem in the 2015 summer A-level paper. So the question goes like this, and I've drawn in a picture that doesn't relate to that function at all, but just to go over the big idea of the trapezium rule. We have to use the trapezium rule with 3 intervals to find an approximation to this integral here. So here what I've done is I've just drawn some random curve to go over the big ideas of the trapezium rule. What we're going to do is we're going to take trapezia of equal width and we're going to use the areas of those to approximate what we've got under the curve. So let me try and draw, there we are, there's the first one, there's the second, there's the third, and there's the fourth. Right, very dodgy. So my formula for the trapezium rule will be given to you, but you won't need it because hopefully what you can see is that the area is going to be approximated by adding up, in this case, these 4 trapezia, right? And if you think about what's going to get counted in there, this wall here is going to be in only one of the trapezia, and so is this wall of the trapezia here. But if you look at these ones in the middle, this one here, I need a different color pen. So this one here goes with this trapezium, but it's also the left-hand wall for this trapezium. So it's going to go in twice, and that's where the formula comes from, right? So it's the 2 end values in once plus double all of the ones in the middle. So what do we have to do to figure out this one? Well, we always start by working out what are our y coordinates. So we've got, we're looking for the integral from 0 to 3, and we want to do 3 intervals. So we're going to make them of width 1 each, right? So that's 3 minus 0, the total width, divided by the number of intervals we want. So that means they're 1 each. Don't need to write that down. That's pretty obvious in this case. And here we've got x, and here we've got f of x, which is the absolute value of 3 to the power of x minus 10. So chucking in those x values in turn, what do we get? Well, 3 to the power of 0 is 1. 1 minus 10 is negative 9, so the absolute value is 9. 3 to the power of 1 minus 10 gives me negative 7, so the absolute value is 7. 3 squared minus 10 is negative 1, so the absolute value is 1. And lastly, 3 cubed minus 10 gives me 17. So these are going to be my y values, right? So these things here are y0, y1, y2 and y3, and y0 and y3 are going to be included once, and these ones are going to pop up twice. So the area is approximately, well, the width of each interval, just writing it out one more time, h is going to be 1. So here we're going to have 1/2 times 9 plus 17 for my endpoints, plus 2 times the rest of the values. Right, so working that out, what do we get? Well, we get 1/2 times 9 plus 17 plus 2 8s are 16. That gives me 1/2 of 42. So my answer is 21. And I don't know my units, but I'm going to put as 21 units squared. So there you go. That's how the trapezium rule works. Obviously sometimes you're going to have lots more values to play around with than that, but the big idea is the same, right? So remember, why do we get this one in once, this one in once, and all of these in twice, and you'll never go wrong with it. I'll do a Simpsons rule video next week. That's not covered in the A level syllabus, but it does sometimes come up in level 3 integration. Thanks for watching.